So we're going to get into the different metric prefixes as well as the equalities, what those prefixes are equal to. And so we've mentioned already that there are certain standard metric and SI units. Those are what are considered the base units. And then those base units, we can add certain metric prefixes to them that increase or decrease its size. And so that's all this one says, is it increases or decreases its size, specifically by some factor of 10. That is 10 to some power. Up here, and you may have been taught that it's the same as moving the decimal, and it is, but the actual math that's going on is we are either multiplying by 10 or dividing by 10 multiple times, depending on which way we're going. Anyway, a kilometer, kilo here literally means thousand, so we have 1,000 meters. A millimeter also means 1,000, but it means that we have a thousandth of a meter. And so again, kilo simply means that we have 1,000, and they have different examples here using the regular units and then the prefixed units. And here are some of the metric prefixes. Unfortunately, this table is split across two screens, but I do want to point out that these are jumps of 3 as we go from kilo to mega to giga to tera. You are probably familiar with those prefixes because of computer speeds or hard drive sizes. Those tend to be measured in these. There are plenty of metric prefixes that go higher. We actually have out to, I think, 10 to the 30 now, adopted in the school year where I'm recording this one, the 22-23 school year. That took us from our previous 10 to the 24 out to 10 to the 27 and 30, as well as 10 to the negative 27 and 30. But these are jumps of 3. If you've been taught in the past some mnemonic to learn your metric prefixes, sometimes U is used there. Those are just jumps of 1. The kilo and milli are jumps of 3 from the base unit. After that, these out here, tera, giga, and mega, those are all jumps of 3, as well as in the other direction, which we'll see on this one. They do include the smaller ones here that are just jumps of 1, deci, centi, milli, and you can see here the powers of 10, or the factor that we are multiplying by. Here we go, then micro, nano, pico. For the jumps of 3 then, and part of why we do those jumps of 3 is just because that's where we normally write the commas, and your brain is really good at being able to quickly identify small clusters. That is, if you drop, say, a handful of pennies on the table, you can count them real quick without actually counting 1, 2, 3, 4, the way that a little kid might have to. If you start to get to piles that are too big, your brain actually does some pretty quick math. It'll notice a pile of 3 and a pile of 4, and then add those two together and say that's a pile of 7. If you get too big, though, you get to where you either have to cluster them yourself, or you actually have to take the time to count them like a little kid, or you do skip counting, like you're counting your evens 2, 4, 6, 8, but you're still clustering them there into groups of 2. But your brain, there's a limit, and there's debate in the neuroscience world whether that limit it's somewhere between 3 and 10, we think, but it's hard to set up an experiment and have people really analyze, was I counting there, or was I just looking at it and knowing? And if I was counting, was I counting or doing quick math? And so we don't know for certain, but basically, because we have the commas in there every 3, we use powers of 10 that skip every 3. It does mention here that micro has 2 different prefixes. This micro here is the Greek letter mu, which was their lowercase m. You'll notice that it looks like a U with 2 tails, but when I draw this one, you'll also notice how that kind of looks like an M as well. Anyway, in the medical world, they use MC for micro, and it's because of the sloppy writing that can cause it to be misread, as well as the fact that this is a Greek letter in amongst a whole bunch of non-Greek prefixes. Anyway, I will tend to go the shorter one just because I'm not from the medical field, and so I tend to write the micro. I tend to overemphasize that first tail a little bit to try to do it, and of course, if you listen, I'll always be saying it that way. But anyway, here are something like from a nutrition label, and you'll notice it has some things measured in grams, milligrams, micrograms, and again, the two different notations. Usually your food labels will only use one or the other. They won't use both. Or say a medicine label, it will use one or the other. And plenty of times it's spelled out as well instead. Anyway, here they're wanting us to fill in the blank, and they've given us a gigantic blank, and so I'm actually going to write it over here to the side. They're wanting us to replace these with the correct prefix. So if we have 1,000, that's going to be 1 kilometer. If we have 10 to the negative 6th, that's going to be 2 of those jumps of 3, and so that's going to be 1 microgram. I'll go ahead and this time write it out both ways, 1 mcg as well. And 0.1, that is going to be 1 deciliter. Now, they also want to emphasize here that these are equalities, that these two things are the same thing. They're two different ways of measuring the same thing. It's not too different than saying that 1 inch is 2.54 centimeters. That's just one that I happen to have memorized. But these two things are equal to one another. Because of that, we can use them as what are called conversion factors if we have a measurement in one unit and want to get it in another unit. And we'll get into doing some example calculations with those here in a bit. Anyway, there are your length equalities where all of these are equal to one another, just as on the last slide. Here, the same thing for volume as well. I do want to point out that over here we get into distance volumes, and it does turn out that we can write this as centimeters cubed or cc's for a cube that is 1 centimeter by 1 centimeter by 1 centimeter, which is one of these tiny cubes they have here in the bigger one. But it turns out that if you have a 10 by 10 by 10 instead, that is the same as 1 liter, or that a 1 centimeter cubed is the same as 1 milliliter. And so those are also equal to one another. And then in the medical world, a lot of times the 1 centimeter cubed or the 1 milliliter is instead written as 1 cc, which is what this next slide has. And so possibly medical shows, you've heard them about needing so many cc's of this medicine or of IV fluid. It's the same notation here, that all three of those are equal. I will say that if you're wanting to convert from a cube, if you have a cube here that is, say, 1 meter by 1 meter by 1 meter, that would be 1 meter cubed. But 1 meter is equal to, say, 100 centimeters. But 1 meter cubed is not equal to 100 centimeters cubed. Because if we relabel the cube there, this is 100 centimeters by 100 centimeters by 100 centimeters. Well, that is 100 centimeters multiplied by itself 3 times, or 100 centimeters cubed. And so it actually turns out that 1 meter cubed is 100 cubed, which comes out to be 1 million centimeters cubed. You're not going to be asked to do volume conversions like that often, but just be aware of it. And personally, I always draw the quick cube here to figure out my conversion in the linear scale, and from the linear scale come up with the cubic scale. Just like with the others, there's the same equalities we have for mass here. I'm not going to take time to go through each of them because it's the same as the prior ones we've done. Anyway, here it asks us to identify the larger unit, and that is kind of the spacing it would be on a measurement, or I personally think it's easier to think of these in terms of if I have 1 millimeter and 1 centimeter, which one is bigger? And so centimeters is bigger here on this one, kilograms is a lot bigger on that one, deciliters is pretty big compared to that one, and milligrams is bigger there. Here we're asked to do something similar, and so 1,000 meters is 1 kilometer, and 0.01 meters is 1 centimeter. And I'm doing these kind of off the top of my head because I know that chart and I've done this for years. There are different ways you can handle it. One is to refer back to the chart and have that on a note card when you take a test. Another is to learn your powers of 10 with each of these and do those conversions. Another is to kind of just memorize the key ones. I would say kilo, your base unit, that is the metric units of grams and liters and meters. Milli and micro are going to be the ones that we use most often this year, and just kind of learn each of those. Another one is there is a move the decimal trick. If you haven't seen that before, I'll let you look it up. But essentially what you do is you kind of memorize the different prefixes, and then you know how many places to move the decimal going from one to the other. And this one here is the same thing. So 1 kilogram is 1,000 grams, and 0.01 CL, that'd be centiliters, which is actually one I'm not as familiar with. Let's see, a centiliter is smaller than a liter, so if I have a tiny amount of centiliters, I'm going to have an even tinier amount of liters. And hopefully you saw my thought process. I'm not making that up. That's actually how I thought through it. Now, I did get through thinking it a hair faster than I said it, but literally that is exactly how I think through one like this when I'm using a unit that I'm less familiar with. Alternatively, I probably could have done it as centimeters and meters, and if I thought of it like that, it probably would have been a quicker jump, because centimeters is the only one that's not those jumps of 3, kilo, base, milli, micro, etc. It's about the only one where it's not a jump of 3 where I've memorized it, just because cc's cubic centimeters, centimeters just in terms of distances being close to an inch, and the English system is one that I'm more familiar with. Anyway, that finishes this section.